Good afternoon. Today I will be introducing a very interesting topic and with the new feature that came from RouterOS version 6.35, and it's very simple but has a very interesting usage. It's the HTB, the abbreviation of Hierarchical Token Bucket. Let me introduce myself. I'm Mohammad Tayyebi, a certified consultant for MikroTik and Cisco certified in CCNA and CCNP. I have a background in the Microsoft System Administrator. I'm working with the Fortinet product, Dell EMC product, and VMware product, and I'm a network trainer. And I have been working with MikroTik from the 2008. My company is Engineer Austin. Is there anyone here from Austin? And from Texas? Oh, awesome. We provide IT training, design and redesign the internet service provider and data center. We have a worldwide client, but our primary location is in the United States and Central America. In our agenda, first of all, we talk about the queue concept and which type of queue exists in the MikroTik Router OS. Then we discuss about the HTB concept, HTB schematic, and bring some example and scenario for them. Queue. When the packet are be buffered or delayed for any reason in network, a queue occurs. So we have a three choice. We can let the packet out, shaping or scheduling. Queue actually used for the limitation and prioritize it, but queue cannot do anything in input data. Queue just control packet in the output data. As you see in the picture, let's assume the blue people is voice traffic. We know the voice traffic must be go out and leave the queue before other type of traffic, and this is an example for queue scheduling and shaping for when the user, one user or two user or three user only, we must pass from or leave the queue at the same time at the moment. We have a shaping. Bandwidth control is set a mechanism that control data rate allocation, delay variability, timely delivery, and deliver reliability. The MikroTik Router OS support this type of queue, and but the important things about the queue is as the Linux term, the packet comes to queue with a function that named queue function, and the packet leave the queue with the dequeue function. The important thing that is the dequeue function. We talk about the dequeue function more. Okay. FIFO has a simple buffer which is defined about queue size, and you can use the FIFO with the packet and byte. But about MQ FIFO, MQP4 designed for the symmetric multiprocessing system with the multi-queue, and they have multi-transmit queue. Red. MikroTik buffers as many as packet as it can, and simply drop the packet. It cannot buffer. But the network congestion happens when the buffers are constantly full or always full. Red, avoiding the network congestion with the controlling the average queue size, and randomly dropping packet when the red minimum threshold reached. What's SFQ? SFQ try to prorate opportunity to transmit fairly. The important things about the SFQ is SFQ work with the round-robin algorithm. Dequeuing function in SFQ working with round-robin algorithm. And there are two positions for SFQ. SFQ is very bad when you have a user who wants to achieve most of connection exist, and in this situation there isn't any chance for other user to get the traffic, get the good connection. It's very bad. It's very unfair. That is why we working on the HTTP and token bucket. SFQ is very nice when the all of your user working same and have a same behavior, and because the SFQ in this situation is the best. What about PCQ? PCQ is similar to SFQ with the, some feature. You can set the source address, destination address, source port, and destination port have also some speed limitation for PCQ. The important things about the PCQ is in PCQ, when you want to assign equal traffic between the user, you must set the PCQ rate to 0. Okay. As you see in the flow, Mangle have a 5 position in the flow. This is why we use the Mangle and Mangle facility. Mangle facility help us to change some field in the IP header, like TOS type of service, DSCP, and TTL. Likewise, Mangle help us to mark the specific traffic and use the mark traffic in the routing table or bandwidth controller. HTTP is a classful queuing method that is useful for handling different kind of traffic. In the HTTP, we talk about the inner queue, leaf queue, level of HTTP, and what's the parent queue responsibility. Inner queue. A queue with the one or more child that attached to it is the inner queue, and the inner queue responsible just for the traffic distribution. And inner queue do not store the packet. And the important thing about the inner queue, priority in inner queue has no meaning. Leaf queue. A queue with a parent and without any children is leaf queue. And leaf queue located in the most bottom level of the HTTP. As we said, leaf queue is a level 0, and as much as you going up in the tree, in the HTTP, in the hierarchical, the level will be added. What's the HTTP parent responsibility? We talk about this. HTTP parent just responsible for the traffic distribution. And you know, the parent or inner is not a real person or a real computer. It's the type of group, type of department, something like this. And but the important thing about the parent is you must, if you want to use the HTTP, you must set the parent in the inner queue configuration. What's the CIR? CIR in MikroTik is the limit at, and data rate that is guarantee for the queue. MIR in MikroTik is maximum limit, and maximum limit is maximum data rate that that is allowed for queue to reach. What is the burst? Burst is a feature for satisfy queue requirement for more bandwidth, even more than the MIR, for a specific time. So we have a two limitation rule for HTTP configuration. Inner queue must be larger than or equal to sum of the leaf queue limited at, and inner queue must be greater than and equal to each leaf queue maximum limit. When a leaf queue wants to be send the traffic, HTTP check its priority. 8 is the lowest priority and 1 is the highest priority. And the priority begin, actually HTTP begin, check the priority from the highest priority in lowest level, and process this to reach lowest priority. We have a tree state. If you have your traffic is between 0 to 50%, your state is green. Yellow for traffic between 51 to 75, and red for 76 to 100%. What's token? We talk about this. The DQ function operation with the round-robin algorithm. And but there is an unfair scenario when you have a user who wants the most of traffic, most of the bandwidth exists. And what is the solution? What shall we do if we have an irregular user? In HTTP, we can control the traffic with something like a virtual ticket, not with the round-robin algorithm. If you have a virtual ticket, you can pass the traffic. If you haven't, you must wait until the specific time comes. This virtual ticket called token. Burst. This queue option was added in RouterOS version 6.35. Before, it's hard coded to hard-coded to 0.1, and now we can set the bucket size from 0 to 10. We can set the bucket size from 0 to 10. Before allowing any packet to pass through the queue bucket is inspected to see if the sufficient queue is already exist or not. And And for the network with the regular user with the same consuming, there isn't any requirement for the use the bucket or token, but the size of this bucket can define how many token are unused in this bucket capacity. We talk about it in the next slide. And bucket capacity is equal to bucket size times maximum limit or burst limit if the burst limit is exist. HTTP diagram. We have a three-part in the diagram. We talked about the blue one and red one, but not for black one. Maximum token rate at any given time is equal to highest value of MIR, CIR, or best. And there are two important things about this diagram. One of them, when we can use the burst. We must set the burst as an active status, and with set the burst item, burst threshold, burst item such as burst threshold, burst time, and average rate. And the other point is the limited when limited at has a highest value extra token need to be issued to compensate for all of the missing token will not borrowing from the parent. And if you have the maximum the limit at as a highest value, you can give a extra token. This part of diagram I'm called the token injection. As we said before, allowing any packet to pass through the queue bucket is inspected to see if we have sufficient token. If we have, we can pass the packet. If we haven't, we must waiting for a specific time. You can see the bucket capacity in the red part that we discussed about the bucket capacity is equal to bucket size time maximum limit or burst if burst exists. If the bucket capacity is full, the token will be dropped. Let's talk about the blue part of the diagram. This part shows exactly which packet comes to take the token. And here we decide about the size of packet queue, the packet queue sequence, the packet queue, which packet queue are added, which packet queue are discarded. I'm back to this slide for offer further explanation. Inner queue just responds, as we said, for the traffic distribution. In case of multi-level queue structure, tokens used in a child queue are also charged to their parent. In other words, child queue borrow token from their parent, and the parent lend the token to leaf queue. But these things happen in the specific condition. We talk about the condition in next slide. When Q rate be lower than CIR, DQ function work with the available token. When the leaf Q rate be between the CIR and MIR, the token borrow from the parent if the token available. And when the leaf Q rate be more than and larger than MIR, the packet in the leaf queue delayed because there isn't any token for achieve. What about the inner queue? In the inner queue, if you have an inner rate lower than CIR, the token lended to leaf. And if you have a speed between the CIR and MIR, the token borrow from their parent and lend to their children. And if your rate larger than the MIR, be larger than the MIR, nothing happen. No borrowing, no lending. We have a simple scenario, as you see, with 3 level. You can see we bring 4 leaf queue and 2 specific inner queue and 1 root. In the leaf queue, we have a C1 that has highest priority. What happens in this situation? We set the MIR and CIR same as each other for the leaf queue. What happened? As you see, the leaf queue with the highest priority take the larger amount of the traffic, and the other traffic and remaining traffic divide to other child. Now we set the limited at for inner queue, and we expect to C2 and C3 take the more traffic rather than C4, C5, and C1. What happened? You can see the C2 and C3 take the more traffic, something like 1 megabyte. And the other is the lowest, have a lowest traffic. Inner with the priority. This is a common mistake. I saw this happen in the many project, many clients, and we can set the inner set the priority for, in the inner configuration, and what happened? What do you think? Is there anyone any idea? The result is you can see the inner with the highest priority can't take a traffic for the leaf queue, and its priority in the inner will not work. Please don't do that. My resource is the wiki of MikroTik, linux-ip.net, and mum.mikrotik.com. Thank you for your attention. Any question? I'm here to respond.
Thank you. Do we have any questions? Okay, thank you.